Hey guys, in this lecture we are going to start a new topic, OOP fundamentals. Uh, Object-oriented paradigm has four fundamental or core concepts: abstraction, polymorphism, inheritance, and encapsulation. And we can memorize it as a pi. So a pi, all right? Uh, But I'm not gonna teach in this order, right? I put it in this order to be able to talk about the API, all right? In this lecture, I'm gonna cover two parts, abstraction and inheritance, and we will continue in the next lectures for polymorphism and encapsulation. What is abstraction? We already mentioned something about the abstraction before. So let's first review what we learned before. So you remember I talked about the water and number, and I explained that how our brain, when we see many instances of water, how our brain will abstract a concept from the water. In other words, our brain removes all of the details and keep just a concept. Let's call it blueprint or template or whatever. It's a generic concept of the water, and also the same thing for the numbers, right? So when we say five, it doesn't mean that five, let's say ball, for example, or five glass of water or pencil or whatever, right? It's just a concept of five. And we call this procedure as an abstraction. Okay, so in this lecture, let me add another example to show you how we use abstraction in our social life. In this example, uh, let's assume that we are talking to our son, and his name is John, and we're gonna ask him to pack his stuff because we are going to a library. So, with this assumption, uh, we consider two scenarios. In the first one, John is 4 years old. In the second one, John is 10 years old. And let's see what's the difference here. Okay, so let's start with the scenario number one. Okay, so here is what we should do. We say, hey, John, pack your book, notebook, pencil, eraser, and a bottle of water. Put them in your backpack. Follow me because we are going to the library. So we need to mention all details because he cannot understand in other cases, right? He cannot understand if we don't tell him exactly what should he do. All right. Now let's turn to the other scenario. John is now 10 years old. So here is what we did for the 4 years John. Now, uh, in this case, when John is 10, we don't need to mention all of these stuff, right? We create a new concept and we call it stuff, right? And we would say, hey, John, pack your stuff. And yeah, even we don't need to say put them in your backpack because, it can be implied from the first one. And even we don't need to follow me. We are going to the library. That's it. So what happened here? So we created a new concept called stuff, right? And we hid the details behind it, right? And this is called abstraction. So in our social life, we have a lot of these kind of concepts that we don't need to mention, every detail. Okay. Let me take other examples. So for example, you use your calculator. The calculator is a, electronic device, right? But you don't care about how it was implemented and how it was constructed. You just use the interface of that calculator to communicate and to use it. Okay. Another example, the numbers. Yeah. When you put a number or when you press on a number on the keyboard, numbers in computer are abstractions, right? We don't care how they really are represented in the computer memory. We just use them, okay? Let me take an programming example. So when you create a Java method, right, you put a piece of code inside a Java method. And what from now on, we just use the Java method name. And this is called abstraction. We are abstracting that piece of code behind the method name. So that method name from now on will be a new concept that it does something for us. All right. So this method, as I said, it's a new concept. And it helps us to reuse this method. Yeah, we will get back to this reusability later. Okay, so the only thing that it is important for us is the method's interface. Whatever we see from now on, from that method, what are they? It's just its name. It's the inputs, the arguments, and the outputs, what the return value is. All right. So these interfaces are important for us. Okay. So abstraction can have many levels. Let me take an example. Let's say we have some pure methods. When I say pure method, it means that inside the method, you are not calling another method. It's just pure a bunch of statements, not calling other methods. Let's say we have three methods, M1, M2, and M3. Yeah, and this is of course the first level of the abstraction. Now let's assume that we create another method. Let's call it M4. And inside M4, we are calling, let's say, one of these guys or two of them. It doesn't matter. So in this case, we are creating the second level of the abstraction. Okay. So this can continue. So, inside another method, you can call M4. This is the third one, and so on. All right. Another examples about the levels. Yeah. We write number 5 on a text editor. Okay. But you know what? There is no number 5 in computer science. Computers, as you know, represent everything, every number by the binary numbers, 101, right? But in reality, computer even doesn't know what is 101 because 101, all of the ones are some transistors that has two states, on or off. When it is on, we call it 1, and when it is off, it is zero, right? But what is transistor? Transistor are some semiconductors, that they work with the electrical voltage and current, right? But what is voltage? Yeah, we can continue a lot. It's the pressure of the electrons. Yeah, but all of these stuff we don't care, right? We just press on the key. Yeah, all of these stuff are hidden behind the key of the keyboard, the key number 5, let's say. Yeah, the key that is showing 5. All of these stuff that we can even continue more, all of these details are hidden behind that key. So we just use the uh, the interface, right? We don't care about the detail. All right. Okay, with this background in your mind, now let's get back to our abstraction officially and let's see how can we define it officially. Okay, so first let's see what's the meaning of abstraction from the etymology point of view. So, so if you just look it up in a dictionary, probably you will see something like this: a general idea or quality rather than actual person, object, or event. Yeah, it's not something real. Yeah, it's a general idea or general concept. Okay, so officially we will define it like this. We would say abstraction is an ability that we have in object-oriented programming, and that ability is to separate the interface from the implementation. So we have this ability to separate the concept from the implementation. Okay, and as we said, we might have several levels of the abstraction in computer science and in the programming. For example, method is one level of abstraction. Class is another level of abstraction. Package is another level of abstraction, right? We can continue this to the layers and the structure of the software, or from here we can go up and say, for example, the symbols, the numbers, and whatever you write on your program, all of them are some levels of abstractions. So what we get from this abstraction? What are the advantages of this, right? So with abstraction, we can break a complexity into some simpler ones, right? So when you want to write a software, right? You break all of the software into the classes, into the packages. So abstraction give you this ability to simplify complex things, right? So when you do that, what you get? Yeah, it increases the readability of the code. So a smaller code is more readable than a very long code. Okay, so what else we get? When we increase the readability of the code, definitely we will increase the maintainability of the code. All right, and also when you can break the whole code into the smaller pieces, you are increasing the reusability of the code. So the small pieces can be written in general purpose, and it can be reused again and again. And also, when you have a smaller piece, testability will be increased as well, because we can test a small piece very easier than a big piece. All right. So in abstraction, when you abstract you can abstract the code, it give you this ability that focus on what the code is going to do, right? Not how, right? When, for example, you create a piece of method here, right? From now on, you can reuse this, and from now on, you don't need to care about how it was implemented. You just use its its interface, as we mentioned earlier, right? So so I I mentioned this fact before, and I want to repeat that to emphasize that abstraction, the concept of abstraction, is so important that if we remove that from the list of the abilities of human, we should return back to the caves. Yeah, that's the importance of abstraction. What is inheritance? Let's see. So first of all, from etymology point of view, if you look it up in the dictionary, let's see what we get. So money, property, etc. that is received from someone else, someone who died. Yeah, okay. From biology, to have a characteristic disease, etc. because of the genes that you get from your parents. Yeah, cool. The reception of genetic qualities by transmission from parent to offspring. Yeah, exactly the same meanings, except probably the first one. We don't inherit money here in the computer science, but the overall concept is the same thing. These are some properties that we get from the parent. All right. So now let's see how can we define officially in computer science inheritance. Right. Okay. Inheritance in computer science is a two-way abilities. Okay. In the first one, we extend the parent class capability. What does it mean? It means that we have a parent here, let's call it parent, and we have a child here, and we inherit from this guy, these parents, all of those things that we want, right? So we can inherit all of the possibilities, all of the, let's say, call them capabilities, the class members, let's say, yeah, in precise terminology, we can say we inherit the class members like this. So this is the first ability that inheritance gives us. What is the second one? The second one is in the other way around. What does it mean? We have some classes, some, let's say, childs, right? So let's call it this class 1, class 2, class 3. Then we see some members are repeated in all of them. We can factor out those members and methods and put it here as the parent, and then ask these classes to uh, inherit from the parent. In this way, we can save some piece of code if there is some common things here, right? All of them are using the same method. We factor out them and we put it here, right? In one place, if they're they need to be changed, at least we change it in one place. Okay, so this is the second ability that this inheritance in object oriented are given to us. And this relationship between the parent and the child is called is a relationship. is a relationship, right? So what does it mean? It means that if you have a parent here and if a child here, right? The child, in fact, is kind of parent because this child is inheriting all of the members, yeah, from the parent. Of course, it's not all of them, but we will discuss in detail later, right? Okay, so is a relationship. Okay, so the parent class is usually more general and it is called superclass, right? And the child is usually more specific and specialized, and it is called subclass. And this superclass and subclass, beside the parent child, actually superclass and subclass are more popular in OOP. But we're gonna use both of them. In some cases, I will use parent child as well. Okay. And as an FYI to keep in your mind right now, and we will cover it later, is this fact that all of the objects that you create, all of them without any exception, they inherit from a mother class that it is called object. This is a class, but it is called object, right? So all of the classes you create inherits from this. We will discuss about this in detail later. Now the question is how we can implement inheritance. I will show you a demo, uh, but let's see first, the code here. Okay, so employee class, yeah, in our example, we have employee class and manager class. Okay, so employee class is, written like this. It has two instance variables here, and it has a constructor that we didn't show here. We will show that later. So we have this set salary and get salary here, and our focus right now is these two. Okay, so all right. Okay, so and we create a manager class that this manager has actually is gonna inherit from the employee class. So we don't need the name and salary for the manager class. The only difference that manager class has that because managers get the bonus, so we just add a bonus in the manager class. So it's an extra attribute. Okay, and also we should note that their salary, is not just the salary that we initialize in the employee class. We need to add the bonus to their salary as well. Okay, so here I repeated the employee class here, and the manager class looks like this. So first of all, it is extending the employee. And so when we say extending, it means that we are inheriting. So we use this keyword for inheritance. We added a new instance variables, and also we have a constructor that we will talk later. And the set bonus, because we added this instance variable, we will have a set bonus and probably get bonus, but we don't care about that get bonus right now. But this is important thing here, because even though it inherits this get salary, but since the salary calculation of the managers are different, we need to redefine this get salary here and to make some changes. All right. Before I show you the demo, let me uh, see that what are these points here. So first of all, as I said, we use the extend keyword for the inheritance. And also you should know that inheritance is an asymmetric relationship. What does it mean? So it means that it's a one-way relationship. Every manager is an employee, but it is not the case that every employee is a manager. So it's a one-way relationship. All right. So the subclass, the manager, I mean, they can have additional methods. In this example, and also, instance fields or instance variables or attributes, right? So in this example, we added a new attribute, bonus, and a new method, set bonus, and also we redefined the get salary, all right? And this redefinition of the parents method has a specific name in OOP. We call them method overriding. So when you re-implement an inherited method in the subclass, we call this procedure as method overriding, right? Just as an FYI for now, know that we have another concept and terms, method overloading, that is totally different than this one, right? So I will cover that later. Okay, so right now let me bring up my Eclipse, and up to this point, let me define the employee and manager class. Okay, so I created a new package for this. Let's create a class called employee, okay. And for the employee, uh, we would need a private string name, and we would need a private, let's call it double salary. All right. So for now, we don't care about the name, but let me create a getter and setter for the salary. For those of you who don't know this, Eclipse can create it by itself. So Alt Shift S, you will get this guy, or you can just go over here and find the source. Yeah, this is the same uh, menu. So go to the getter and um, setters. So we need getter and setter for salary for now. All right, generate this. Okay, so this is the employee. Now we create another class. In this class, we call it manager, but we can say that you see here the superclass, all of the classes that you create, the superclass will be that object class that we're going to talk about later. But for now, we want to extend the employee, right? Even though it's just two class, but you need to learn that how you can find that employee. Um, like this, right? So we would say that we want to extend this, and everything looks good. And so this is the manager class. To see it side by side, let me look at this in this way. Okay, so what was the manager class? It has a bonus, so private double bonus, right? And what else we have? Okay, So as we will see, some of these stuff will be inherited here in the manager, but uh, so since we defined a new one, new instance variable, we would need a getter and setter for that. Again, Alt Shift S, and we go to getters and setters, and we can say, okay, generate it for me. All right. Okay, so our code is almost ready. Let's go ahead and see what we need to demo. We just introduced a new relationship between two classes, parent and child, or superclass and subclass. All right. Now, before going further, let's see how we can represent this relationship with UML. So, yeah, we have a flashback. What we learned before, we learned that there are 6 relationships like this, right? And we have already covered these 3, right? Now, this time we are gonna focus on the inheritance, right? And also, we know that for every relationship we have a connector. Let's review them as well. Yeah, these are those relationship and those connectors that uh, we have covered, and now we want to talk about this inheritance that it looks like this. All right. So as we showed in the previous slide, the connector looks like this, and when we have class A inherits from class B, this relationship is shown by this class B, class A. So in this representation, class B plays the role parent, and this guy is child or superclass or subclass. All right. Okay. So for our employee and manager class, we have the same thing here. So employee, manager. Yeah. All right. And note that the tip of this arrow is pointing to the parent guy. Okay. And let me show quickly that how we can use the violet for representing this parent-child or this inheritance relationship. Okay, so this is the violet 2.1. You go to the class diagram. So we have 2 classes here, 1, 2, and the connection between these 2 guys will be this guy inherit from, right? So like this. Okay, so we can add, as usual, the all of the members here, the instance variables and whatever, right? So let's see, the name is employee, and you can add the attributes here. For example, name, the salary, right? And you can add the methods here. To save some time, let me forget about that. So the manager. Okay. I put some exercises here for you guys to draw the UML class diagram. Okay, now let's see how we can implement the inheritance, but in detail. Let's go in detail and see what's happening. All right. So up to this point, we learn what the inheritance is, how we can show it by the UML diagram, but really some questions and very important questions raised here. So for example, what? Yeah. So what members of superclass would be inherited? This is a very important question, right? How we can invoke the superclass constructors. The third question is how can we invoke the superclass methods? And is there a multiple superclasses inheritance possibility? Can we inherit from more than one parent? These are very important questions, right? And if you want to use effectively the inheritance, we need to be very clear about these stuff. Okay, so let's visualize first these two classes. I completed the all of the instance variables and the methods that we really uh, you know need in this part of the lecture, right? So let's see. uh, Employee class diagram declares all of the members, and in the manager class we just mentioned the differences, right? All of those stuff that are gonna be inherited from here, we don't need to mention here, right? Just the differences. We have the set bonus, and also here I just ignore the get bonus as well because it's not our concern right now. uh, the get salary is important because here the get salary is different, right? And we need to override it here. And yeah, that's it from here. All right, probably you're asking, hey, what are these pluses and minuses here and here, right? Okay, that's a valid question. So those are actually the access modifier. You remember that we said we have four access modifier: public, protected, package or default, and private, right? Each one of them has its own sign in the UML diagram. I summarized them here in this table. So public is plus, this is the pound sign, the protected, package is this tilde, and minus is for private thing. Okay, so now let's get back to our questions. Yeah, so considering this picture, which is the UML class diagram, let's answer the questions. First, what members are inherited? Okay, all right. In summary, we would say all visible members of superclass would be inherited. So that's a very general answer. All visible members. But which members are visible, right? We have seen some stuff about this visibility of the members, but it was not complete, as we said before, and we said we will get back to them, right? Okay, so let me get back to the visibility stuff first. Review whatever we know already, and then we will add this inheritance relationship that we just learned. Okay, so let's assume that we have one classes here. Let's call it my class, and in the same package we have other class A. In the new package B, we have my class sub. It means that this class is inheriting from the my class, and there is another class in that package, other class B. All right, and all of these classes are looking at the my class. You see this guy is looking at this, my class. And the question is, what do they see from the my class? Which members are visible? All right. Okay. So to save some time, I summarize all of the visibilities in this table. Okay. So my class, these are the members of the my class. Yeah. If a member is public, what would happen? If a member is protected, what would happen? Package or default and private, right? Obviously, all of the members of the my class can see whatever is inside the my class, regardless of the access modifier. So these are the members of the my class itself, right? They can see all of everything, right? Now, how about the other class A that we are talking about? This guy. This guy, what members of the my class can see, right? So the public is obvious, the protected and the default or package are obvious. The only thing that this guy cannot see is the private. So private is, specifically for the my class, right? Nobody else can see that member. Okay. So, in summary, if we have a class in the same package, this guy can see all members except the private one. Now let's focus on this one, my class sub. Okay, so my class sub uh, is, exists in another package, but it is inheriting from the my class. So this is the inheritance um, sign here, right? The connector, right? Okay, what members this my class sub can see? You see all the public, which is we are not surprised, and protected. So the protected can be seen. Yeah, that's the difference that I said before. There is some subtle differences between the package and the protected, right? Uh, and and here is the explanation. So if it is protected, it can be seen by other classes who is inheriting from the my class, right? So, but this is not the case for this guy, right? This guy is in another package, and it can only see the public ones here, right? Other class B in this row, you see, it just can see the public guys. All right. So this is the difference between the, inheriting a class and not inheriting a class. So since this my class sub is inheriting from here, so it can see all of the public members and also the protected members. Now, based on this knowledge, let's see what does manager class have. So first of all, we defined a new instance variable bonus. So definitely manager class has the bonus, right? And also it is inheriting all of the public things, which are these three. Excuse me. And what else? You know, a new defined method that is set bonus here. Yeah, I didn't mention the get bonus here. We don't care about that right now. And also the manager class overridden the get salary. So in summary, what the manager class has, all of these three, but they, get salary is overridden. So this guy will be overridden, right? And also this set bonus, okay? And also the bonus which is inside the manager class, of course, it has access to that. So just look at this name and salary, both of them are private. So directly, the manager class does not have access to them, right? But it can, I mean, the manager class can have access to them via the methods, all right? Okay, so let's see what we got here. Uh, we can declare in the subclass an instance variable whose name is exactly the same as the a variable in the superclass. We can do that, but never do that. It's not a good idea, right? Here I put an example. For example, the salary, we have the salary instance variable in the employee class, right? You can create another one for yourself in the manager, but never ever do that. That's not a good, uh, design. The other question is how to invoke superclass constructors. Okay, uh, I'm gonna give you a demo regarding this, but let's see what we have in this slide. So the attributes in this case are name and salary. Okay, and to instantiate the name and salary in the manager class. So in employee class, we know how to instantiate this, but the question is, how can we instantiate these two guys in the manager class? All right, we need to call the superclass constructor, but the question is how? We want to answer this question that in when you are in the subclass, how can you invoke the superclass constructor? Let me create a constructor here. So I'm gonna instantiate both of these guy, right? So we can use um, these facilities that Eclipse gives us. So generate the constructor, right? Yeah, I can create a constructor for both of these, generate, you see. And yeah, we don't need this super here. So this is a regular constructor for the employee, right? Okay, now the question is, if I want to instantiate a manager class here, how can I call that constructor? Yeah, so let me create a main class here. All right. Okay, so manager, let's call it man, equal to new manager. All right. So, okay. So we don't have any constructor in the manager class here, right? So with this statement, we are calling uh, the zero parameter constructor or the default constructor of the manager. But in this way, I cannot instantiate the name and salary for the manager. So I would need a constructor here to be able to pass the name and the salary to that the constructor of the employee. So let me create this constructor here, manager. So let's say, so we would need the same argument here. All right. Okay. Now the question is, how can we instantiate this? How can we call the employees constructor, right? And this is the point. We use the keyword super, right? And we pass the name and the salary, and this guy will be called by this super and name and salary that we are passing to exactly this constructor. All right. Now, in this instantiation here, I need to pass this name and the salary. So let's say the name is Tom and the salary, which is a double, let's say, for example, and you know that we can use the underscore to separate uh, the numbers, something like that. All right. So yeah, we are done here. So we instantiated the manager, and with this technique, we are calling the employees constructor. So we responded to this question: how can we call the parents constructor? In summary and in brief, we would say by using the super keyword. All right. Okay, now let's see what we got uh, here. Yeah, exactly here I mentioned the whatever I said, but in the employee, I just use here in this code the name, not the salary, right? And here I explained that how we can use the super keyword. All right. Now let me give you some points here. So yeah, here I explained that, but I put it here for your reference that we need to use the super keyword. But here the point is it should be the first statement, right? If you have another statement and you put it, not this first one, the Eclipse will complain and your code won't be compiled. All right. And also I explained about this zero parameter constructor that Java, if you don't mention any constructor, it will automatically create a zero parameter for you. Okay. The next question is how to invoke superclass methods. Okay. All right. So let's get back to our employee manager code. So here, uh, let me see. Okay, so this is the employee class. Um, and here we are trying to override the get salary. So let's focus on this part. Okay, so to write this correctly, we would need to access to this get salary or the salary of the employee because manager doesn't have a salary. It is inheriting the salary from the employee. So how can I put the salary here? Can I say, for example, salary plus bonus here? And can I expect that this salary is coming from this salary? Probably not, because we learned that this salary is a private instance variable or member, right? And this salary, doesn't make sense. We don't have access to the private thing here, right? All right, so this is a problem. Yeah, that's a problem. So how can I access to this salary? Probably via the get salary, right? Okay. So in this scenario, I would say get salary plus bonus. All right. Do you see any problem right now? Yeah, probably yes. Because when you say get salary, what's the what is the point here? What is the, issue here? It calls itself because it's closer to this method. Yeah. So first Java will invoke this get salary. So it will be a recursive call. So how can we fix that? Yeah, probably you are um, guessing that that super keyword is the solution. Yeah, exactly. So we need to distinguish between this get salary, between these two superclass and subclass, and we will be using the super keyword. All right. And so how about the other methods if you want to call, for example, so this class, this get salary was overridden. Is this the case that for calling other methods, yeah, other methods won't be a recursive call, right? For example, if you, let's say, get name, we don't have get name in manager. So if you want to use get name in the manager class, should we use the super? Yeah, that would be the optional, but it's a good practice. If you are calling something from the super class, try to always mention this super. So super point and then the name of that member, whatever it is. And also I explained that we inside the, when you want to use a self member in a class, you can use this for all of the members of this class. All right. Okay, so let's get back to our code and let's see how can we do that. Yeah, super get salary plus the bonus. The last question is about the multiple inheritance. In other words, can we inherit from more than one superclass? Yeah, yeah, the response is Java does not support it. All right. In some programming languages like C++, yeah, this is allowed, but in Java it doesn't. And the reason is because it increases the complexity of the code, right? As a developer for many, many years, let's say 3 decades, I have never felt that I would need to do something like this. Okay, so this is a observation from a developer, a veteran developer point of view. Okay, so to show the Java developers has this joke like this. So if this is the class, and if you want to inherit from a bird, and if you want to inherit from a horse, then you end up with this unusual and imaginary creature, right? Okay, so um, another point here, if you tag a class as final, it cannot be extended. All right. And also, if you tag a method as the final, it cannot be overridden, right? Let me quickly show you this. For example, if this is an employee class, and if I say final, right? Here you see it is complaining. It cannot be, it cannot be extended anymore, right? And in Java library, the string, for example, is a final class. All right. Okay, so let me remove that. And let's say I want to create this guy as a final, right? And if I try to, uh, let me see, if I want to try to um, override it here, let's say public um, double get salary. You see, again, it is complaining, right? Okay, guys, uh, you can see the explanation here. Cannot override the final method from employee. All right, that's what I had for today. See you guys in the next lecture.